In today's video, I will teach you how to solve a system of equations of order 2 times 2 using Cramer's rule. We will first cover the theory and then use numerical examples, so stick around for both. This video requires you to know how to calculate determinants of order 2. If you don't know how to calculate this yet and you have not watched my video on determinants of order 2, I strongly advise you to do so first. The information in that video will be necessary to understand this one. I will link the video in the description and you can also find it on the top of your screen. If you learned something after watching this video, please help me out by liking and subscribing to my channel. With that out of the way, let's get straight into this. On your screen you can see a system of linear equations. The solutions are in red because this makes things more clear later on in the video. As you already know, the system of linear equations corresponds to the following matrix, which we call matrix A. It is a matrix with entries A11, A12, A21 and A22. We can then find the determinant of A by multiplying the main diagonal and subtracting the multiplication of the off diagonal. We then get A11 times A22 minus A21 times A12. Now we have to calculate x1 and x2. We start by writing down the division symbol after both. The denominator is going to be the determinant of A for both x1 and x2. We just saw the determinant of A. Now, the denominators are a bit different. For x1, the denominator is the determinant of A, where the first column is swapped out for the solutions. So A11 becomes B1 and A21 becomes B2. Now you also see why I put the solutions of the initial system of equations in red. It makes things easier to see where they are placed in the solution for x1. The solution for x2 is similar. The difference is that we now swap the second column of the determinant of A for the solutions. So A12 becomes B1 and A22 becomes B2. We are not working out this example because it will make things more difficult than necessary, but we will now solve a numerical example. On your screen you can see the system of equations 2x minus y is 4 and x plus 3y is 5, as well as the corresponding matrix consisting of entries 2, minus 1, 1 and 3. We call this matrix B. Let's first calculate x. The first thing we do is draw the division sign. The denominator is the determinant of B. The numerator is the determinant of B, but with the first column swapped with the answers of the system of equations. This means that 2 is swapped out for 4 and 1 is swapped out for 5. We can now calculate this division using the rules for determinants of order 2. For the numerator, 4 times 3 is 12 and 5 times minus 1 is minus 5. 12 minus minus 5 equals 17, because minus negative becomes positive. For the denominator, 2 times 3 is 6. 1 times minus 1 is minus 1. 6 minus minus 1 equals 7, also because minus negative becomes positive. The final answer for x is therefore 17 over 7. Now we are going to calculate y. We again first draw the division sign. The denominator is the determinant of b. The numerator is the determinant of b, but with a second column swapped with the answers of the system of equations. This means that minus 1 is swapped out for 4 and 3 is swapped out for 5. We can now calculate this division using the rules for determinants of order 2. For the numerator, 2 times 5 is 10 and 1 times 4 is 4. 10 minus 4 equals 6. For the denominator, 2 times 3 is 6 and 1 times minus 1 equals minus 1. 6 minus minus 1 equals 7, also because minus negative becomes positive. The final answer for x is therefore 6 over 7. That brings us to the end of the video. As a reminder, I would kindly like to ask you to please like this video and subscribe to my channel. This will make sure many more people will learn something from this video. See you in my next video.